In this video, I will be solving the first part of the second problem of UPSC Civil Services Mains 2017 Statistics Paper 1. So let x1, x2 and so on xn be independently and identically distributed observations from a distribution with probability density function f. If y is an unbiased estimator of theta, so then variance of y is greater than or equal to 1 by n into expectation of dou by dou theta log f of x whole square. So we need to use this inequality to show that the sample mean is a uniformly minimum variance unbiased estimator of mean of a Poisson distribution. So basically we are asked to use this inequality, which is nothing but the Cramér-Rao inequality, to show that the sample mean is the UMVUE of the Poisson mean. So let x1, x2 and so on xn, so they are like IID with this PMF or PDF f theta of x, and this y is nothing but this g of x1, x2 and so on xn. So is an unbiased estimator of theta. So then variance of y is greater than 1. So this is like clearly like Cramér-Rao lower bound, CRLB. So if we take like for a single observation, like suppose xi follows Poisson lambda. So probability of x is equals to x is e to the power minus lambda, lambda to the power x by x factorial, and x is 0, 1, 2 and so on. So we can see like the mean is, so basically our theta is our lambda. So parameters are lambda, which is mean of our Poisson distribution. So the log likelihood is nothing but log of this f of x, so which is nothing but minus lambda plus x log lambda minus summation log xi. So that means dou by dou lambda of this is nothing but minus 1 plus x by lambda, which is x minus lambda by lambda. So basically the information matrix would just be expectation of dou by dou lambda, lambda of the log likelihood whole square, which is expectation of x minus lambda by lambda whole square. So which is nothing but 1 by lambda square into expectation of x minus lambda whole square, which is nothing but our variance of x by lambda square, and variance of Poisson distribution is lambda itself. So basically we'll be getting the information as 1 by lambda. So Fisher information for one observation is 1 by lambda. So Fisher information for n observations, for n IID observations would just be in of lambda, which is n times I of lambda, which is n by lambda. So therefore like the variance of lambda hat is always greater than or equal to 1 by the information, Fisher information for this n distribution, for this n IID observations, which is 1 by lambda by n. So therefore like if we take the sample mean x bar as 1 by n summation I is equals to 1 to n xi, so we can clearly see expectation of x bar is lambda, so which is unbiased, and variance of x bar is nothing but variance of this xi divided by n, basically n times variance of xi by n square, which is variance of xi by n, which is lambda by n. So variance of x bar is nothing but this lambda by n, which is nothing but our Cramér-Rao lower bound. So that means the sample mean attains the Cramér-Rao lower bound. So now since x bar is unbiased and its variance attains this Cramér-Rao lower bound, so it is the uniformly minimum variance estimator of this lambda. So therefore x bar is UMVUE of Poisson mean lambda. So that's it for this video. We'll meet in the next video.